Yes, and if you start with the Microsoft analogy, then I've actually started with I don't know. So let's try, let's have a competition. Let's get a bunch of people that are students and give them something that is absolutely never seen before and see what they can do with it, and you'll be amazed that they actually write code around a bug, and you will end up with like a 5% yield of some group that you didn't imagine. The professors will actually tell me, don't do this because you're going to be disappointed. And I challenge them back and I say, no, let's do it. And you end up with somebody that's doing something to get to that chip, to get to the end game. The second thing on the capacity, on the, yes, the 200 millimeter wafer fabs are not going anywhere. This is physical material there. You said longer runway. No, they're actually, nobody said that they're actually going down. They're going to keep going because there are businesses run with them. There are chips that are being 20 years in manufacturing, they're still being done. So this is very hard to change, and it's a very high cost to get it even to 300 millimeter for the same technologies.
Yeah, Mac, I think that, it's very perceptive, because one of the implications of not having a market driven by scaling alone is exactly this, which basically says, now it's time to go and look back at what we might have left in our wake as we went through it. We've all been around here, certainly anybody with hair that looks like mine, knows that primarily microprocessor development teams would get 8 to 10 times the performance / power / functionality / density that a typical ASIC design would get. But it was okay. They had an economic reason for going in and basically fine-tuning the processor. The ASPs were high enough in the marketplace to do it, and following the scaling made perfect sense. In the most recent years, that's not the direction at all. More ASIC methodology, because what was important? Architectural change, because I was already limited by power, and I didn't need to have the next 6 gigahertz processor out there. I needed something that did more workload with it, right? And so the design community started moving early, right? They still used the process nodes, they still had economic benefit and advantage for certain types of design to do it, but you started to see the tail in terms of utilization of manufacturing capability to start spread out, because a lot of applications didn't need the front end, right? What you're hearing here, and I think everybody is all over the top of, is that it's now, what are you integrating together for what purpose, how efficiently, what is the cost associated with it, both in terms of real cost as well as time to market. And those vectors are going to be very valuable to people. And that ultimately gets back to the point that you were saying is there enough economic motivation for tool suppliers to go back and more shrink wrap things to make the process of using them better? I don't know about that. What I do know is that for intellectual property providers to package whatever the tool had to do so that I had the flexibility to use that piece of IP where I want to use it now, huge value in that, right? So I don't know where that trade-off is of, intelligent teams that know how to use current technologies to give more flexibility to design. And so you wrap that up into a package that says, I've got a need for an ultra low power Bluetooth LE XYZ for an embedded that I'm doing, wearable. And someone says, oh, I wrapped up exactly what you need so that you can take that piece of IP and use it today. And whether that was a tool improvement or a thing, they're not going to care. Back to the I don't care about that.
So I actually think that whoever's not going to adapt to this is going to die. This is actually a change that has to happen. And I say that if the economic motivation to do it is, if you don't do it, you're going to be left behind. So today, people are worried about the business, and I'm sorry about that, tipped your around here, but it's today, people are afraid of changing their business models and the way they do things because there's existing revenue that's being protected by a certain category of customers. Changing that from the big customers, big few, to small, many, everywhere, that's a business change that the economic innovation is against it, actually. Whoever's going to do it right is going to survive.
for the EDA industry. A lot of respect. Not just because I've been in it for a while, but the fact is that the only way people have been able to access the capacity that the semiconductor process has been able to bring has been with companies on this floor, large companies on this floor, that took the challenge and the incredible risk of coming up with products they were not ready, and they knew it, but the customer wanted it because they would rather have product not ready today than a product ready 2 days from now. So having taken this risk is a fundamental way you do business. I think is deserves a lot of respect.
And it's the same for microprocessors. So we keep saying about how custom microprocessor without knowing the microprocessor that was built in huge capital. Now we know.
I was in a company that I can tell you we didn't know where the processor would go. I've been public on that many times. But the interesting on your level of abstraction, and then on your level of abstraction, that's one of the most interesting ones. To get the world to move to a different level of abstraction, than just the ESL level. I mean, I personally, I'm not saying just forget it. We've seen people investing on ESL for 15 years. When finally this gets accepted, guess what? There are people there that have 15 years. And when finally it gets there, of course it's not going to be ready. There's a change in methodology. So when people start using it is when really you find out the damn thing doesn't have this, doesn't have that, but why you're using it? Because you have no choice. At this point you have to move your level of abstraction. And I welcome the fact that at this point that level of abstraction is there. At the same time, and we'll talk about this later after we take this question, at the same time, I'm looking at what we're talking about here, and we're really changing the level of abstraction again of the design we're making. So we'll go back to that in a minute, think about that one, and we'll get this question.
Okay, so I'm going to take a little historical step back, Ted Rose, from the last century. So when you look at the history of this industry, it started off with the IDMs. And after a while, things got a little complicated, and they said, we need to focus on certain core competencies, and they started releasing all the EDA stuff out, and the EDA industry happened. And then a few years later, this fabless semiconductor industry came up because the IDMs couldn't keep up, not all of them could keep up with Moore's law. And then as you progress forward, then the IP industry came along saying, okay, guess what, all of us are designing, how many more USB designs would you like? Okay? So that's the third level of abstraction that has happened. So my question is, in line with the title of the session, what's next? What should we be expecting in the form of core competency that will create another industry or another level of abstraction?
Well, I think the way that we started up first was to recognize what to think is you've got to be masterful at integrating things together, understanding market need, as Mohammed said, very agile in the marketplace. If you look at the software side of the universe, right? So let's say there's EDA software, there's banking software, there's application software. What you'll see is successful software companies today all talk about minimum viable products, agile design techniques and methods, getting something into the marketplace with an experimentation infrastructure so the market is telling you what you need, and rapid integration of what they tell you back into the product, right? And so that's your customers on the outside, right? We've been chasing the scaling demon for years and years and years, and that was a hard enough problem. And now that one's slowing down, but this one is accelerating. And so how am I going to differentiate? If I'm going to go sell to a Qualcomm today, how many of you would like to sell software technology to Qualcomm? Come on, be honest. You would, right? All right. Who are you selling to? How many of you have gone and looked at the Qualcomm website? They sell Snapdragon. Everybody knows Snapdragon is really important to them. But did you see that this is a Qualcomm iBeacon, right? It's not the Bluetooth transceiver that's in here that they're selling. They're selling a cloud-based service on how to put 1 billion of these out into use and manage them in the field. And as Warren said, it's an entire software stack from what's on here, through what's in here, through what's in the cloud someplace. And so, Lucio, when you asked the question, what should this look like? More of those automotive areas, which is exposing the totality of how what you do relates into what people are selling and needing in the marketplace today. And it's not academic, it's the real world. There's a huge excitement around how I can go and take something that used to work this way, make small amounts of modifications integrated with that, and have a new rapid opportunity, because guess what? The marketplace is in exploration mode. And I'm hoping that we have a little bit of time for Lucio to maybe comment a little bit at some point about what's the capitalization structure have to look like so people with great ideas out here and people with great ideas in IP can actually, in this world of integrating things together, have a better chance of having a successful entrepreneurial startup that ends up with something useful.
So I'll tell you, Flextronics, the company. So at some point in the past, I didn't even know what that means, except like flexible electronics or something. But if you actually, I got to visit on an investor day, I got to visit a whole tour of the whole campus 2 weeks ago. These guys they build many small variety of products. The Google Chromecast, it is the whole product, the board, the 3D print, the package, the whole thing. So if I imagine here, I would say, okay, I need a system that I sit in that gives me the ability to envision the whole product, everything, make trade-offs on IPs, make trade-off on form factor. I see I want to pull in a microprocessor. No, not the whole microprocessor, the core, okay? And I'll take this, how does it fit? Is it going to look like what? Having a vertical integration system, it doesn't exist. Everybody here, you can't even do the board and I see the same page. So we know that. So that needs to change this way, vertical all the way to mechanical systems.
The way I like to think about this is using an analogy from the music business. And the way I think about the CD and its predecessor, the LP, and cylinders before that. And at each of these times, you had be able to put more and more data on these devices. Now, what comes from that? The innovation comes from that. People said, we can record music on that. We can get one song on one of these cylinders. And then maybe we can get a whole album. Storage, capacity, and as a result of that, then you start to have an industry of artists. And artists, when Elvis, the world didn't stop with Elvis. Then there became the Beatles, and then Nirvana. And so I see silicon as being this platform where content is applied to what Bob said. And the objective of the companies here in the EDA is to provide that platform where the artists can come alive and distribute their work to the masses.
Very well put.
Mike, your question.
So when you were holding up devices earlier, it struck me that a number of these devices were defined and built in extremely large organizations using very conventional kinds of design approaches and financing approaches and everything else. It also struck me that some of those devices, or ones very similar to them, have been, at least in their infant forms, produced by different kinds of designers. So it seems like there was a discussion of expanding the definition of system designer, expanding the definition of product entrepreneur, and some of those I think have been done based on crowdsourced financing, so even expanding the definition of financier. And so I wonder what the implication of that is in the design automation space, because I have no freaking idea.
We have a master that has a theory that's really good if you care to share it. Of course, it could be patented secret, so I don't know.
I think one interesting aspect let's all talk about this. One interesting aspect of this community that we are talking about, we're not saying clearly. If we're designing small devices, they go in several different applications, again, from my hat to my hands to my shoes to with my glass or whatever, to thermostats to sharks, go anywhere. If this is what is really happening, and if it's true that these end-use companies have no intention of creating their own internal design team, if that's the situation, where are these designers coming from? Where are they going to? Where are they? Are they going to get into a community of 500 people and start a company with 500 people designing things from sharks to heart? I doubt it. So somehow, the only solution you can see is that there is going to be a distributed ecosystem, a distributed community of designers which are happy to stay where they are, wherever their country is, wherever their school is, wherever their home is, and they are just a virtual company that is available exactly to present the designs and the solutions to problems that are incredibly creative, problems that are incredibly new and require therefore incredible creativity. If that's what they're looking at, if that's the structure they're looking at, you have to start thinking, what is that they are looking for? Are they looking for somebody to give them money to do something, or looking for somebody that give them maybe money, but also an entire platform, an entire infrastructure? So I'm not going to go to somebody, can you give me $100? I'm going to somebody say, do you have an infrastructure that allows me to do this thing? Can you really let me access that infrastructure? And by the way, I also need $100, but the infrastructure is far more important. In a sense, it's more like a Pixar for design, a Pixar for products. It's all there. All I add is just make my creativity to make the movie. I want to add my creativity to make the specific device that does the thing I think people will really like. I think there might be a situation in which the entire structure might move more in this direction. But how it's going to go and comment about it, that's, what is it, Mike? That's a crazy way of looking at it. But
So,
who knows?
I want to give you an example. How many people know here a company called Local Motors? Local Motors versus General Motors. Local Motors is a company that makes cars locally, customized. So people can get in. A car, let's say you have an idea of an improvement in an engine. Good luck trying to sell it to Ford or GM or I guess it's the same company. So, but if you actually have worked with Local Motors, they will look at your idea, work it with you. They have a concept. It's called micro factory. They deploy the micro factory in a region where the community of hackers come in, put things together. But there's a company behind that actually street certifies the cars. Go look it up and see. You can actually order custom cars. And it's community based, but there's a way to monetize it. It's not a big company, it's still new. So I've become a believer of something. After I left TI in April 2011. So this is 3 years. I've seen a statement by someone. It's called, "No matter who you are, the smartest people of the world don't work for you." I have data to show that. There are people that I have met that you cannot hire. They have the full integral visibility of the whole system. They have a 3D printer sitting around, and at the same time he's routing something and shipping it to a fab. Weird setup, but they exist. And if you give them the connection to a consumer, and you give them resources like IPs and EDA industry that enables them to assemble that and show it to the consumer in such a way that the consumer can say that the drone is not or that, that's how it should be the industry. It's just the ability to let the customer or consumer envision the artist's use of the material, which is the IP, the existing everywhere, to produce that beautiful piece that somebody wants.
Isn't that great? I mean, so think about it. I mean, I was just listening and reflecting back, and Lucio, the way that you stated that is, I think, perfect, because it integrates the fact, like Warren, you said, there's a new palette. the IP that we talked about early on, it's new colors in the palette. The technologies that we've already spent 30 years investing in are the tools that help us to take those colors and that palette and create a new painting. The marketplace is out there that's already in the software world. Trust me, nobody builds software for consumer marketplace today the way they used to. They don't. That's gonna eventually show up down in how the people that you're talking to right today to build these embedded systems, which I'm sure many of you are interacting with companies there, or chips, it will impact the way that those have to be done as well. Except for the ones, by the way, which are the large volume things that everybody knows they have to invest in the next fabs for. But we're not talking about those. That's not necessarily where the growth space is. That's not necessarily where the number of design starts, right? If you're willing to sort of say design starts are system design starts, there is an exponentially exploding opportunity.
For your customer's customer, your test is when somebody asks you, how much did you sell? You said $10 million, whatever. How many chips, how many designs came out? If the answer is I don't know, then you fooled your customer. That's a metric. If you know, you say, all these products have been designed with my product, my system, then you actually solve the customer's customer problem, to enable them to succeed.
So, at the risk of further sniper fire, I'm not so optimistic about this level of crowdsourcing type thing for this industry, because I think you have to look at the software industry, what's happening in software, and we all saw basically Solaris destroyed by Linux. Armies of people volunteering for free to put together that software. Now, why did they do that? By and large, I think the research on this has shown, I want to be famous. I want to contribute to something big that's on every platform, that's on all these servers. I want my stamp on that thing. Now, that's in conflict with what we do in semiconductors. Okay. Today we have hobbyists, and the FPGA company has done a wonderful job of making your weekend hobbyists to be able to design just amazing things with completely free tools. And you can do that all day, but the volume is very low. The problem is if the volume gets very high, then you, as the entrepreneur that did that, are not going to make a business out of that in FPGA. Broadcom's going to take that. So it's not a direct analogy exactly on how that kind of innovation can be, but I agree with you guys that the agility that people need to move, and I think big companies, big semiconductor companies, can really benefit by not assigning 500 people these projects, put 5 people on it. Yeah. Put your 5 best guys on this and leave them alone. You'll be amazed what they could do.
But the access to a community of creative people is fundamental.
Yes.
Fundamental. And one of the points you made, I will make exactly the opposite way. That is, I agree that lots of people contributed to Linux and Unix and whatever, and they were in fact driven not necessarily just being famous. They were driven by the fact that they were at the same time seeing the end of what they wanted to achieve and the difficulty in the tools to achieve. So they say, okay, I'm going to just change the tools to this little thing that is not doing yet, so I'm going to add it in and do it. And that's how it ended up going. My view is that one of the things might be happening in limited segments, but might be happening is exactly the same thing. And people will start using more the spice-like thing than the set of tools we have today, because they're solely small stuff. If I really have to go from here to there, and the only thing I have as a problem is the little puddle there, I just fix the puddle. I know how to do that, and then I go back on my path. So I think that might be a situation in which if this community really happens, and really is powerful and creative, and therefore successful, we'll find out also the tools to support them will come in a very different way.
So
That's my
I want on
yes.
this. Just you mentioned that large companies do put out 500 people. So companies are different, different markets. So analog, for example, if you ask a company that is selling for smartphones, they will find tens of customers. If you go with analog, 70,000 customers. The product lines, they have 3 engineers and two test engineers, a marketing or business responsible, and then the sales organization is on top. You're going to find that you're saying not optimistic. I say that's a change that's going to force these organizations already structured in a way that is small trees hanging from a specific building like this. The change that we're talking about here is just having these trees just fly and go somewhere and become local. So the 3 engineers, what are they getting out of this umbrella? The sales channels. So they need a business connection to the consumer, and they need manufacturing, and they need design technology. So this is how it fits together.
So if there is one more question from the audience, we'll take it.
You really want me to ask you a question?
Absolutely, Eric. The most pragmatic individual to likely ask the question.
Actually, this isn't really related to this. It's just been a curiosity to me from the beginning. So, Ted, did you or Alberto pick out Lucio's tie?
I wish I could take credit for that.
Okay, well, I think no more
There you
questions.
have it.
You want to make any final
I
comments?
just want to comment on the title of so another type of design automation. Instead of looking at design automation, I was talking earlier, Lucio, we're solving design productivity, a productivity problem. The design automation industry, when it spun out of the IDMs, it was a productivity problem. A productivity problem means how can you get the solutions for the product faster? That could be the people, the tools, the hardware, the ubiquity of where the people are, having a community to solve problems. It doesn't matter, but it's a system. You put a problem, on the other side it comes a quick solution that fits what the customer needs. That's the productivity. We need an automation of the word productivity rather than a design automation.
Let me do one final comment that just to follow to Mohammed's comment. I want to remind people when we started Daisy System, I didn't start. I joined when they already started. But when this industry started Daisy System, it was a very interesting time because everybody thought that Daisy System was this company that would take the techniques of designing within larger companies like Intel and just make it available to all designers, so there was going to be something more horizontal for the people that are doing design. Well, the truth is that specific idea failed miserably. The way the industry happened is because there was a huge community of people that wanted to do designs. They were not in the semiconductor companies, they were in the system companies. They didn't want to do designs like microprocessors, they wanted to do very simple stuff like gateways. They're very creative people. They were trying to do one chip that would just solve some of their problems, and that's what they are looking for, tools. So the only way the industry took off was by doing better what Intel was doing inside or TI was doing inside, but by doing something for different people, for a new community that was coming up of IC designers that were looking for gateways and standard cells, nothing else. I'm not that smart, I just do those little things. That's how this entire industry started. 31 years ago, in 83, 82, when the first commercial portion of the DSC happened, that's exactly what we had. We didn't have anything smart. We had little stuff, well, gateways and standard cells, nothing else. But the community was there, ready to do new way of designing, new way of attacking different applications. It was not going to be the same memories and processors that everybody had. It was just stuff that they thought about and was important. That happened a little more than 30 years ago. And what we're talking about here conceptually is not very different. So might that require different kind of tools to roll them? Is there going to be just bringing in an enormous different set of designers that are not there today? Absolutely, positively so. I have no doubt in my mind. So how we serve them, How successful will be in how many different applications? They will be successful, but where they will be successful, we don't know. But we have in this situation the same situation that happened when suddenly people developing application software were not doing it for the PC, they were doing it for the phone. Those are people everywhere. You don't know what they're developing. You know who did that application. Nobody knows. It's a huge community of people. I think we're getting close to that. And I hope it's going to be that way because it's going to be much more fun and much more exciting when we do it. Thank you.